These were the special angles I told you about. See these? Must know them. Must. Have to. You see, when we start trig identities and equations, if you do not know this, I am telling you, if a trig question comes, like I am 1000% sure, one of these would be involved. If you don't know the exact value, or you don't have a calculator that would give you the exact value, like the Casio gives you the exact value. But if you don't have a Casio or a calculator that gives you the exact value, and you don't know these, well, then it's all, well, not all downhill from there, but these questions are with some high marks. So you might lose like 2 marks. I mean, maybe to you, I don't know, maybe to some people that doesn't seem like a lot of marks, but it adds up. So remember, 1 mark could making 1 mark could be the deciding point if you get a 1 or 2 or 2 or 3 or 4. You see where this is going, right? So you can't afford to lose any marks, right? Learn these. Please learn them. It will come. It's not like one of these topics where, it's a 50-50 chance of coming. No, you have to learn it. Have to know it. It will come. Okay. So let's just go through this real quick. If I have sine of 0 degrees, 0 degrees is the same as 0 rad, right? Radians. So if I have sine of 0 degrees or 0 radians, 0. Cos of 0 degrees or 0 radians, 1. Tan of 0 degrees or 0 radians is 0. Sine of 30 degrees, also known as pi and 6 radian, is a half. Cos of 30 degrees or pi and 6 radian is root 3 on 2. Tan of 30 degrees or pi on 6 radian is, you might see, root 3 on 3 or 1 on root 3. They're equivalent, right? If you put that into a calculator right now, root 3 divided by 3, you'll get 0.577, right? And a whole long decimal. If you do the same thing with 1 on root 3, you'll get the same answer. These two values are what we call mathematically equivalent. It's the same thing, right? Sine of 45 degrees or pi on 4 radians, it's root 2 on 2 or 1 on root 2. Just like this, these are the same. Cos of 45 degrees or pi on 4 radians, root 2 on 2 or 1 on root 2. Notice these are the same. Tan of 45 degrees or pi on 4 radians, 1. Sine of 60 degrees or pi on 3 radians is root 3 on 2. Notice these are the same. This is the same. Cos of 60 or pi on 3 radians is a half. Tan of 60 or pi on 3 radians is root 3. Sine of 90 is 1, or pi on 2 is 1. Cos of 90 is 0. Tan of 90 is undefined. Undefined. Okay. If you put tan of 0 in your calculator right now, I suggest that you do it so you see it yourself. Because like I said, don't just accept what I tell you. Make sure it's true, right? Question it. Find out
Did it and it came up 0.
Hold on. Hold on. Yeah. Okay. You got 0.
Yes, miss, I got it.
Mine say maths error.
It's supposed to say error. That's what undefined means. Undefined and 0, not the same thing.
Yeah.
Right. Hold on. Your calculator is in which mode? Degrees or radian?
Wait, mine is radian.
Who told me that the answer is 0? I don't think it was Troy told me.
No.
No, I was referring to the first one.
Oh, okay. Well, Yeah, this is undefined. Just remember that your calculator is in radians, right? So if you need to switch it back to degrees, remember to do that. Okay. So once you pull it up in a test that you have, I don't know, maybe tomorrow, and your calculator is in radians, but they ask you to do that. That's the end of that. You have to know this. Please learn it. If you don't, you will suffer because it will come, and I will show you a question just now. Gosh, time almost up on me. Length of an arc. Lower level math or regular math. You need. I think you would know if you reach that topic. Can't remember what. I think it's Form 4 you learn this. But the formula to find the length of an arc in degrees when the angle theta is in degrees. Very important. Let me circle this. Hold on. In degrees, when theta is in degrees, this is the formula you use to find the length of an arc, of the arc. What do I mean by the length of the arc? You see this right here? So let me use figure that. See this? That is called the arc. If I use this formula, I would find this length. When theta, the angle, is in degrees. Remember that, right? Don't mix them up. Do not mix them up. You'll get it wrong. And they want you, well, for this topic, the name of the topic is, well, the big heading is radians. So you need to know the formula for when angle theta is in radians. This is the formula. Length of arc, L, which is denoted by L, so the length of arc is denoted by L, is equal to r theta. R being the radius, theta being the angle in radians. So these are two different formulae, right? This is finding the length of the angle, length of the arc when theta is in degrees. This is finding the length of the arc when theta is in radians. Do not mix them up. Okay? Everybody good?
Yes, miss.
Yes, miss.
Remember, my voice telling you don't mix them. Area of a sector. In regular math, I don't know if you learned this yet, but you will learn it because it's on the syllabus. Area of a sector, you would learn in regular math, or probably learned already, and the area of a sector when the angle is in degrees is theta 360 times pi r squared. But this topic is dealing with radians, so you need to know the formula when the angle is in radians. To find the area of a sector when the angle is in radians, it's a half r squared theta. What do I mean by the area of the sector? Well, you see this thing here. This is my sector. The area is everything in here. That's the area they're referring to, right? Everybody good?
Yes, miss.
All right. Time to practice. Yay. Okay, we're not doing this one right now. Don't focus on that one. It looks like a lot of words on the screen. That's why I crossed out that, right? But we're not focusing on number 2 right now. Focusing on number 1. What to do with it? Let me do this switching. Right. So I'm doing this one with you. Just copy down the question and let me know when you finish. We'll go through this one together.
All right, miss. I got the main points from the question.
Okay. This is silence me, no? Okay, going once.
Miss, what happened? Miss, your audio is kind of cutting out for me, miss.
I asked if everybody was finished copying on the question.
Oh, okay, miss. Now I can hear you better. And yes, I am.
Okay. Well, let's do this. So first thing you want to do, I always tell them, for this question, for these type of questions, it always helps to do a little sketch, right? You don't have to, but take my advice, it helps. So they told me, what did they tell me? Hold on. Did they tell me circle? Okay, yeah, they told me circle. They told me a circle has a radius of 8 cm. So what I would do, obviously it wouldn't be this big compared to my paper, but this is just to show you, right? I would have a little sketch. Like I said, you don't have to, but I do recommend doing this sketch. This is my radius. I was told that this is 8 centimeters. And they told me a sector. What did they want me to find? They wanted me to find the length of the arc when you see this angle here. So this is also the radius. So it's also 8 cm. Why is it the radius? Well, the definition of a radius is the line that connects the center to the circumference of the circle. Center to the circumference. So this is the radius, which is 8 cm, and this is also the radius, which is 8 cm. So this right here, this thing highlighted in blue, this is the sector that they're talking about, right? This whole thing is the sector. And they told me that this angle here is 3 pi on 4 radians. What do they want me to find? They want me to find this length, the length of the arc. Let me name that L. We know a formula. When the angle is in radians, we use the formula L is equal to R theta to find the length L of the arc. Okay. So what did they tell me? So they want me to find this. So this would remain L is equal to R, which is my radius. They told me that the radius is 8 cm. So I'll put 8 here, theta. Theta is 3 pi on 4. So this is multiplied by pi on 4. Therefore, all I need to do to find the length of this arc is to punch this into my calculator and, get the value. Can anybody tell me what's the value?
What's that, miss? I'm gonna calculate it.
Okay. So just 3 significant figures is fine, right? But like I said, it all depends on the question asks you. But like, if they don't tell you anything, 3 significant figures is the
18.84.
3 sig figs. Wait, I'm saying significant figures. Do you know what significant figures are?
Yeah.
Yes, miss.
Yes.
Okay, good. Because I'm here repeating the same thing. And I don't know if you know
No.
the same. Like I keep saying that, but I don't know if you understand what it's talking about. Okay, so it's good that you understand. So 18.8. If you want, put 19, but 3 significant figures or 2 significant figures is the standard way to go, right? 18.8, 19. So yeah. Everybody good with this?
Yes, miss.
No questions, right? So can I move on to the second part of this question?
Yes, miss.
All right. You don't need to call me miss. I'm so formal. Okay. So we're given. Hold on. What do they want me to find? They want me to find the angle. So I could use the same formula. Why? Why would I use this formula? Well, they told me for the second part that the length of the arc is 6 cm. So it makes sense to use this formula. Why? Because if I want to find theta and I have L, which is 6, and I have R, which is 8, it makes sense to use this formula, right? So you could, it's your choice, right? So since you want to find the value of theta, the first thing you could do is make theta the subject of the formula, right? So theta would be equal to L on R. Or, oh, well, let me just finish this one. Theta is equal to the length on the radius, right? We know length is 6, radius is 8. Somebody give me an answer. This one is easy, you don't need to
3/4.
3/4 or 0. Okay, well, I'm using 3/4. But is this in degrees or radians?
Degrees?
Okay, I have one put for degrees. Anybody else? Degrees or radians?
Degrees.
Yeah, I put degrees or radians. One more person.
75. 0.7.
75. Yeah, but degrees or radians?
Any one of them.
No, that's not how it works. It's one, either one. Degrees or radians?
Degrees.
Mm. Okay, well, sorry to say, but all of you are wrong. Why? Okay, it's okay. Here's where we learn. It's okay to get things wrong. Just need to learn and fix our error so we don't make the same mistake next time. I told you that there are 2 formulae when finding the length of an arc. One is for degrees, one is for when theta is in degrees, and the other is for when theta is in radian. What am I doing? Right. So L, oh, sorry for leaving. It's okay. Right. What was I saying? So for the one with degrees, L is equal to 360 on theta on 360 multiplied by 2 pi r. This is for degrees. There's another one. L is equal to r theta. This is for radian. Now, tell me, this formula that we use here is the angle in degrees or is it in radian? Anybody?
Radian, miss.
Radians. So don't mix it up, right? It's okay to make mistakes now. We just fix it for next time. So it's in radians. So I could put the C or I could put rad. Everybody good with this? Or I could put the 0.7 as well. 0.75 and rad. Everybody good?
Yes, miss, I'm good.
Okay, that's one person. How about the others? You good?
Let's see, just go over it, please.
Which, oh wait, you get bumped up. So the whole thing,
Yes, please.
part A and B or just B?
Just be.
Okay. Let me- Is it fine if I leave the writing here or you want me to write it over?
Well, Miss, you can leave it there.
I miss, I'll take a screenshot of it.
Okay. So what I was saying. For part B. Okay, part A, they gave us the angle. They wanted us to find the length of the arc. That's this with the yellow arc. For part B now, they gave us the length of the arc. They told us it's 6 centimeters. So this entire thing here. And they asked me to find the angle. What I was saying is that this formula, I mean, you could have used this one, don't get me wrong. But that's not the point of this exercise, right? It's to use radians. Because most likely in your exam, they would ask you to find the value of theta in radians. So that's why I use this formula. L is equal to R theta. We have L, we have R. So therefore theta is equal to L on R, right? That's just me transposing. If R is multiplying on this side, divides on this side. Okay, all I have to do now is substitute my values. So since I know that theta is L on R, I know L is 6 and R is 8. So theta is equal to 6 on 8, which reduces to 3 on 4. The question I was asking was, is the angle in radians or is it in degrees? Everybody said degrees, but I was explaining why that is wrong. This formula here, this formula is used when theta is in degrees. However, we use this second formula here. The second formula, theta is in radians. So what does that mean? The unit for 3 and 4 is radians, not degrees. So it's strict quarter radians. Or you could put the 0.75 radians. You good there?
Yes, Miss.
So let me just show you one thing. You know here I made theta the subject of the formula before I substitute my values. I was saying you don't necessarily have to do that. I do recommend doing that too, like making it the subject of the formula, but you're trying to find the subject of the formula. But if you wanted to, you could have substituted your values right away. So I know L, which is the length of the arc, is 6. So you put 6 is equal to R is 8 theta. And then you transpose is equal to 3 and 4. All right. So the first method, well, the first way, I made theta the subject of the formula before substituting my values. And this way, I substituted my values and then I made theta the subject. Like I said, doesn't matter, but I do recommend you making theta the subject first and then substituting your values. Okay? So I'm coming off of this now, right? That's okay?
Yes, miss, of course.
Yes, Miss.
All right. Past paper time. Yay. I think it was Josh that was asking me this. Look at this. Hold on. Remember when you were asking me if to put the value, when you punch it into the calculator or leave it as pi. Don't write down this, Don't write it down. See this? Giving your answer in terms of pi. That's what I was saying. It would tell you if to put it in terms of pi or if to, find the actual value. That's what I was saying. It all depends on the question. But actually, yes. We're doing this question now. You don't need to write it down though. You could just take down the year. So it's paper 2, 2012, number 4A. That's what we're doing right now. You don't need to write down the whole question. I posted all of them in Google Classroom already. So just take down the year. Attempt it. You do it by yourself, and then I'll go through it with you. 5 marks. Come on. If you get this, you get 5 easy marks. Okay? So I have faith in you. You could do this. Wait, before you do that, let me just show you this real quick. We're not doing this today, right? This is the other part of traits. But look, sine of pi and 3 is equal to root 3 and 2. Right. Yeah, they gave you this one, this special angle. Yeah, they gave you this one. And they gave you this. That's not always the case though. Here they give you the special angles. Sometimes they don't. They expect you to know it. That's why it's very important for you to know what to do. And it's not always with only 3 marks. These could be with like 5 marks, 7 marks. So that's why it's important for you to know what you're doing. Right. So number 4A, try it yourself, part 1 and 2. This might take a while, so like 5 minutes, and then we'll go through it together.
Excuse me, miss.
Yeah.
For that angle on top there, miss, on that shape, it is pi over 3, right?
Yep.
Okay, miss,
Yeah.
sorry, I was just having a little bit of hard time seeing.
Okay. Okay. That's okay. Is that better?
Yes, miss, that's better.
Okay. Nice. Let's make it. I need to stop with this. Let me read through the question. Did anybody do this past paper question yet? In school or by yourself?
No, miss, I haven't.
People who sat in exams this year. You did this? Okay, it's very important if you sit in exams this year. People who sit in exams next year, okay, you have some time, right? So you get a black. People who sit in exams this year, though, see these past papers, you have to do them, all of them. I mean, I will do all of them in class with you, but you also have to practice on your own, right? It's very important. Okay, question. Paper 2, 12, number 4, part 8. The diagram shows a sector of a circle center, of course I can see that, O, with an adjoining square. The radius of the circle is 4 meters. Let me just tell you now, this time, they gave you a diagram. They don't give you a diagram all the time. That's why I told you it's helpful for this subject, well, this topic, to, do a little sketch first before you start your calculations, because they don't always give you the diagram. You need to figure it out yourself. Okay. If the sector AOC subtends an angle pi and 3 at O, right here. So this is my sector AOC. This is my angle pi and 3. Calculate, giving your answer in terms of pi, very important. So you have to give it in terms of pi, right? The area of the shape OACMN. Okay. So that's the whole shape. That's included here too, right? So it goes like this. Can I hear your thoughts about this? Anybody? Just one person.
Very good, very nice.
Okay. So they want me to find the area of this whole shape. Let me try to draw it. Drawing skills are not great, but I will try it. Hold on, let me. So I have a sector. Go like this. This is my sector on top, and this is my adjoining square. Oop. Well, let's just pretend that's a straight line because I'm not trying to go. This is O, A, C, M, N. This. Actually, let me just draw it. This is pi on 3. Oh gosh, that's too much white. Oh gosh, that's not. Pi on 3. And this is 4 cm. They also showed me that this is 4 cm. First part, they want me to find the area of the entire thing. So not just the area of the sector, not just the area of the square, the area of this entire thing. OACMN. So this whole thing. How would I do that? Well, the total area, to find the total area of this shape, so let me just put total area would be the area of the sector. So I'll just put area of sector and the area of this square. Everybody following so far?
Yes, miss.
How do I go about finding the area of the sector? Well, we know a formula. When the angle is in radians, like this, pi on 3, I know the formula to find the area is a half r squared theta. And then I also know that the area of a square is side by side. Everybody good, right?
Yes, miss.
Okay. All I have to do now, substitute my values. So let's do that. Oops. R